Proportion test. A proportion test is a statistical method used to compare proportions or percentages between two or more groups to determine if the difference is statistically significant. It is commonly applied when analyzing binary outcomes, e.g., success, failure, yes, no, defective, non-defective, to test whether the observed proportion in one group is equal to or different from another group or a known standard. Typical examples include comparing conversion rates, defect rates, or survey responses. Proportion tests are essential in quality control, marketing analysis, and medical studies where decision-making depends on differences in proportions rather than means. Welcome, everyone! Before we dive into the session, let me give you a quick overview of what we'll be covering today. By the end of this session, you'll walk away with practical knowledge that you can immediately apply in your role, especially around the topic of proportions in statistical testing. We'll be focusing on two key types of proportion tests. First, we'll explore the one proportion test, where we assess whether a single sample proportion is significantly different from a known or hypothesized population proportion. Then, we'll move on to the two proportion test, where we compare the proportions of two independent groups to see if there's a statistically significant difference between them. These tools are essential when you're dealing with categorical data and want to make confident, data-driven decisions. Let's get started. In this slide, we're looking at a common situation in hypothesis testing, where both the response variable, y, and the factor, x, are discrete. This typically means that both variables have only a few distinct categories. A typical example is when y is binary, such as quality being marked as pass, fail, and the factor x is also binary, like two different work shifts or two machines. There are two types of proportion tests used in such cases. One proportion test is used when we want to compare the proportion of a specific outcome in a single sample against a known or expected standard. For instance, if we expect a 95% pass rate and want to test if our current process meets that benchmark. Two proportion test comes into play when we are comparing proportions between two groups. For example, comparing the pass rates between Shift A and Shift B to see if there's a statistically significant difference. Understanding which test to apply depends on whether you're comparing to a known standard or between two independent groups. We'll explore both in detail in the upcoming slides. Let's begin by understanding the one proportion test. This test is used when we want to compare an observed proportion from a sample to a known or expected proportion, often called a target or historical benchmark. For instance, imagine a manufacturing process where the historical defect rate is 5%. If we run a new batch and find that 8% of items are defective, we might want to test, is this 8% significantly different from the expected 5%? That's exactly what the one proportion test helps us answer. Now, when should we use this test? First, the data must be binary, meaning outcomes are classified into two categories, like pass, fail, or yes, no. Second, we are only comparing one group to a known standard, not two groups to each other. Lastly, it works best with a sufficiently large sample size to ensure statistical validity. We'll look at the assumptions and steps shortly, but this gives you a good foundation for when and why you'd apply this test. Before we run a one proportion test, it's essential to ensure certain assumptions are met. These assumptions help maintain the accuracy and reliability of our results. Let's look at the four key assumptions. 1. Sample size must be large enough. The rule of thumb is that both NPA and N1P should be at least 5, where ON is the sample size, OP is the hypothesized proportion. This ensures the sampling distribution of the proportion can be approximated by a normal distribution. 2. Observations must be independent. Each data point should not influence another. For example, if you're checking defect rates, one item's result shouldn't depend on another's. Independence is a core assumption in all hypothesis tests. 3. Only for binary outcomes. The test is only valid when the data is binary, such as pass, Josh, fail, yes, no, or defective, non-defective. If the response variable has more than 2 categories, this test is not appropriate. Beware of confusing statistical and practical significance. A result can be statistically significant but may not be meaningful in the real-world context. For example, a 0.5% improvement in quality may be statistically significant, but it may not be practically important or cost-effective. Keep these assumptions in mind before proceeding with the test to ensure your conclusions are valid and applicable. Let's take a deeper look at the one-proportion test. This test is used to determine whether the proportion of an event occurring in a sample differs significantly from a specified or historical value. We use it to make inferences about the population proportion based on sample data. We base this test on 2 competing hypotheses. The null hypothesis, H0, assumes there is no difference between the sample proportion and the specified standard. In other words, any observed difference is due to random chance. The alternate hypothesis, H1, suggests that there is a difference, meaning the observed sample proportion is statistically significantly different from the benchmark. Let's quickly go over the 3 key sections shown below. 1. When to use the one-proportion test when you want to compare the proportion of a specific outcome in your sample, like the proportion of passes, to a predefined target. 2. Null and alternate, OH0. Proportion equals standard, AOH1. Proportion not equals standard. This is usually a two-tailed test unless specified otherwise. Examples. Suppose AIG wants to test whether the pass rate for 700 students is 80% or not. Another example is checking if the defect-free rate in a production process is 97%, as expected. This test is particularly useful for quality checks, survey results, or any binary outcome scenario where you have a benchmark to validate against. Let's now look at how to perform the one-proportion test using Minitab, which is one of the most widely used statistical software tools in Six Sigma and quality analysis. To access the test in Minitab, follow this path. Go to the Stat menu on the top menu bar. Hover over Basic Statistics. From the drop-down, you'll see several hypothesis tests listed. Click on One Proportion for running the one-proportion test. For two-proportion comparison, you can choose two proportions just below it. Once selected, Minitab will prompt you to input your data or enter summary statistics like the number of trials and number of successes. This slide is helpful as a quick reference for navigating to the right tool within Minitab, and we'll go through an example shortly to see how the test is run step by step. This slide shows the dialog box that appears when you select the one proportion test in Minitab. Minitab provides you with two input options for running this test. 1. Samples in columns. Use this when your raw data is stored in a column in the worksheet. For example, if your column contains pass or fail values for each unit or transaction, you can select that column directly here. 2. Summarize data. This is ideal when you don't have the entire data set, but you know the number of successes and the total number of trials. For instance, if you know that out of 500 products, 475 passed, you can enter 475 as the number of events and 500 as the number of trials. Below that, you also have an option to perform the hypothesis test. You can enter the hypothesized proportion here. Say 0.80 if you're testing whether your process meets an 80% pass rate. This setup makes the test highly flexible. Whether you're dealing with complete data or just summary stats, you can still run the analysis in Minitab with ease. Now let's look at how to interpret the result from the one proportion test in Minitab. In this example, we are testing whether the observed proportion of non-attrited individuals differs from the hypothesized value of 0.25. Here's what the output tells us. The sample proportion, sample P, is approximately 0.349. The 95% confidence interval ranges from 0.233 to 0.479. The p-value is 0.109. Now, the most critical element here is the p-value. According to the interpretation guideline mentioned, if the p-value is less than 0.05, we reject the null hypothesis and conclude that there is a significant difference between the sample proportion and the specified value. However, in this case, the p-value is 0.109, which is greater than 0.05. This means we failed to reject the null hypothesis. So we do not have enough statistical evidence to say that the observed proportion is significantly different from the hypothesized value of 25%. Please also note that the text at the bottom of the slide contains an interpretation error. It incorrectly says, since p-value is less than 0.05, while the actual value is 0.109. So, in our delivery, we should correct this by emphasizing that the p-value is not low enough to be statistically significant in this case. Let's now move on to the two-proportion test. This test is used when we want to compare the proportions of a certain event occurring in two different populations or groups. It helps us determine if the observed difference between the two proportions is statistically significant. First, let's understand the hypotheses. Null hypothesis, H0. There is no difference between the proportions of the two populations. In other words, both groups have the same proportion of success, failure, defects, etc. Alternate hypothesis, H1. There is a difference in proportions between the two groups. When to use it, this test is applicable when you want to compare proportions across two independent samples, such as comparing pass rates, defect rates, or satisfaction rates between two groups. Let's look at a few examples. 1. AIG wants to test whether the pass rates of students in 2016 and 2018 are significantly different. Second, you may want to compare the defect rates between two separate assembly lines in a manufacturing process. The two-proportion test is a great tool to objectively verify if performance has changed over time, or if one group is performing significantly better or worse than another. Now that we've seen when and why the two-proportion test is used, let's define it more formally. The two-proportion test is a type of hypothesis test used to compare binary outcomes, like yes, no, or pass, fail, between two independent groups. It answers a very practical question. Is the proportion of a certain outcome in Group A significantly different from Group B? For example, is the defect rate in production line 1 different from production line 2? When should you use it? Here are 3 key conditions. Your outcome is binary, e.g., success, failure, defect, no defect. You have 2 independent groups, e.g., 2 different shifts, years, teams, or suppliers. You're interested in comparing their success or failure rates. This test is very useful in quality control, customer feedback comparisons, training effectiveness assessments, and many other operational decisions. We'll look at how to run this test in Minitab and interpret the results in the following slides. Before we run a two-proportion test, we need to make sure that certain assumptions are satisfied. These assumptions ensure that the test results are statistically valid and reliable. Let's go through them. 1. Binary outcome. The response variable must be binary. For example, success, failure, pass, fail, yes, no. The test is not suitable for continuous or multi-category outcomes. 2. Independent groups. The two groups or samples being compared must be independent of each other. That means the outcome of one group should not influence the other. 3. Repeated. Independent groups. This looks like a design repetition in the slide. It might have been a placeholder or oversight. However, it's still worth reinforcing the point that independence between the groups is absolutely crucial. In summary, the two-proportion test is valid only when the data is binary, and when the two groups being compared do not have any overlap or dependency. We'll now move ahead to see how to run this test in Minitab and interpret the results. Now let's look at how to access the two-proportion test in Minitab. To perform this test, follow these simple steps. 1. Go to the Stat menu in the top toolbar. 2. Hover over Basic Statistics. This will display a drop-down menu of statistical tests. Select 3 proportions from the list. This option is used when you want to compare proportions between two independent samples. For example, comparing defect rates between two different production lines or pass rates between two different years or departments. Once you click on Two Proportions, a dialog box will appear where you can input either raw data from 2 columns or summarize data by entering the number of successes and total observations for each group. We'll explore that dialog box and how to interpret the results in the next slide. This slide shows the dialog box that opens when you select two proportions in Minitab. You'll notice that Minitab gives you 3 options for entering your data. 1. Samples in one column. Use this when your binary outcome, like attrition, yes, no, is in one column, and the grouping variable, like designation, analyst, or manager, is in another column. In the example shown here, attrition is selected as the samples column. This contains the binary outcome. Designation is selected as the subscripts. This indicates the group each row belongs to. 2. Samples in different columns. Use this if each group has its own column for binary outcomes. For example, if you had 2 separate columns, one for Shift A and another for Shift B3. Summarize data. This is used when you don't have row-wise data, but instead just have the counts, i.e., number of events, e.g. passes, and total trials, sample size, for each group. You can also click on Options to set confidence level, alternative hypothesis, and other preferences. This flexibility allows Minitab to work with both raw and summarized data, making it convenient regardless of how your dataset is structured. This slide explains the first way to input data for a two-proportion test in Minitab, using samples in one column. This method is ideal when your dataset is stacked, meaning your response variable, CY, is stored in one column. Your grouping or factor variable, X, is stored in a separate column. In the example shown, column C1 contains the binary outcome, whether an employee was attrited or non-attrited. Column C2 contains the group identifier, the designation like executive or senior executive. When you choose this option in Minitab, you'll specify attrition as the sample column. You'll specify designation as the subscripts or group identifier column. Minitab will then calculate the proportion of attrited in each group and perform the statistical test to determine if the proportions are significantly different. This structure is simple and very common in survey or HR data, where binary outcomes are tracked across categories. This slide explains the second way to structure your data for the two-proportion test in Minitab, using samples in different columns. This method is suitable when you have unstacked data, meaning the binary outcome for each group is stored in separate columns. This layout is often seen when the data is already split by category or level, like different worksheets maintained by different team leaders or departments. In the example shown, one column contains attrition data for the executive group, Another column contains attrition data for the senior executive group. Both columns contain the binary outcome values, such as attrited or non-attrited. When using this option in Minitab, you'll specify these two columns under Samples in different columns. Minitab will then analyze the data and compare the proportions across the two groups. This format is useful when data has been pre-sorted or separated by categories. For instance, data collected individually by two shift supervisors or from two separate regions. This slide shows how to interpret the output from a two-proportion test in Minitab. Let's walk through the key elements. The test compares the proportion of non-attrited individuals between two designations, executive and senior executive. The sample proportions are O executive, 12 out of 34, 35.29%. O senior executive, 10 out of 29, 34.48%. Now, look at the difference. The estimated difference in proportions is only 0.008 or 0.8%. The 95% confidence interval for this difference is wide and includes 0 from negative 0.228 to positive 0.244. This tells us that the true difference could be negative, positive, or 0. There's no conclusive evidence of a real difference. The most important part is the p-value, which is 0.946. Interpretation. Since the p-value is greater than 0.05, we fail to reject the null hypothesis. This means there is no statistically significant difference between the two groups' proportions. Additionally, the Fisher's exact test also gives a p-value of 1.000, which further confirms that the proportions are not significantly different. So, in simple terms, based on this data, we conclude that attrition rates between executives and senior executives are statistically the same. This slide provides a quick comparison between the one-proportion test and the two-proportion test, both of which are applicable when your response variable, y, is binary. For example, pass/fail, yes, no, good, bad, etc. Let's break it down column by column. One-proportion test. When to use? Use this test when you want to compare a sample proportion to a known or expected standard. This is useful when validating performance against a benchmark. Hypotheses. OH0. Population proportion is equal to the reference value. OH1. Population proportion is not equal to the reference value. Examples. OAIG wants to check if the pass rate for 700 students is 80%. OA manufacturing firm checks if the defect-free rate is 97%. Two-proportion test. When to use? Use this test when you're comparing the proportion of an event between two independent groups, like different years, locations, or teams. Hypotheses. OH0. The proportions in both groups are the same. OH1. The proportions are different. Examples. OAIG compares pass rates for 2011 versus 2012. OA manufacturing firm compares defect rates between two assembly lines. This table is a great reference for deciding which test to use depending on your scenario, whether it involves a single sample or a comparison between two groups. It also helps reinforce the structure of hypothesis testing for binary data.